concepts and the MapReduce concepts. And follow to that, I'm going to explain the Hadoop 1.x and 2.x comparison. So what are the drawbacks? What are the key points in the Hadoop 2.x? So by understanding the limitations of 1.x and 2.x, probably will be no, I'll be explaining about Hadoop 3.x. That is the features. This is the latest version available in the market right now. And also I have one video about the Google data center, because almost all our data are stored in the Google data center. So I'm going to play that video to have just know about how the rack, what are the data nodes. We generally speak about the rack and the nodes, right? So maybe in the real time we can see the racks and the nodes, and even the execution, how it happens in the data centers. That is Google data centers. And finally, I'm going to summarize, and if there is any questions for me at the end, I'll be happy to address the questions. So this is the outline of my presentation. And if you ask me the outcome, so at the end of this afternoon session, the participants will get those outcomes, like they'll understand the MapReduce process, and they will be understanding the different cluster types available in Hadoop. They'll be understanding the different versions available in Hadoop and their advantage and the limitations. And finally, the Hadoop understand the features of 3.x latest version of Hadoop. So these are the outcomes. So I am sure that if you attend the session at the end, each one of you will have this outcomes. And these are the takeaways for this afternoon session. So with this, I hope my outline and the outcome is clear to you all. And with this, maybe I'll start with my first slide. So okay, so let us start. So here comes the introduction, like what is MapReduce. So before the introduction, maybe I can revise the topic, what we have seen in the morning session. See, morning session, we understood what is a big data analytics, because it is more important to know the big data analytics before we start with the Hadoop, because Hadoop mainly suits to run big data concepts. And also we understood with the different examples, and follow to that, we understood what are the problems we are facing with the traditional approach. So the mainly we categorize into three problems. One is for storage. So big data has a huge amount of storage, but in a traditional database, a traditional approach, we have a less quantity of storage. So it is very difficult to store a huge amount of data. There is one problem we identify. And the second problem is, when it comes to big data, the types of data what we have is a different one. We have a variety of data available. We call this a heterogeneous data. So we have a different types of data, so it will not suit, it will not match with the traditional approach. So that is our second problem we have seen. And third problem we analyzed is the accessing and the processing of huge data. So even there also we have a lot of issue like bandwidth and the failure. So many issues we have in the traditional approach. So that is a third problem we have identified. So for all these three problems, I gave an assurance that we are going to address those problems by using an Hadoop. So in a morning forenoon session, we discussed about the HDFS, Hadoop Distributed File System. Through HDFS, we came to the conclusion that we can address the first two issues. That is, issue number one is, I can say that storage part, because Hadoop allows the big data storage data to store in a distributed environment. So that we have addressed. And also when it comes to the heterogeneous, partially we addressed in the HDFS. Even we are going to see how to handle the unstructured data in MapReduce by using also. So these are the two problems we addressed in the morning session, and we left with one problem, that is accessing and the processing of huge amount of data, and what is the solution for that. So the solution is a MapReduce, which has the component of Hadoop. And also we have seen how the HDFS architecture and how we can perform the operations like write, read operations, and how if any data node fails or any node fails, what are the actions will be taken. Even we have seen some real-time examples like how the Google works, how the Gmail works. And so these are some of the examples we have seen, and we concluded the morning session. So here the continuation to that, we are going to address the third issue, that is accessing and processing of huge amount of data. So with this revision, I would like to continue here with MapReduce. So MapReduce is one of the component in Hadoop. Here the Hadoop MapReduce says it is a programming model for processing the large set of data sets with a parallel processing. Okay, we have a huge amount of data. So all the data, if I have a single node to process everything, just think how much time it will take to complete the task. But here Hadoop provides a programming model called as MapReduce, which performs the processing in a parallel in a distributed algorithm on the cluster. Because whenever I say the cluster, there will be it is in the distributed environment, and it will be processing in all the jobs will be processed parallelly. So that is one point. And when it comes to second one, MapReduce when coupled with HDFS. So HDFS we have seen in the morning session can be used to handle big data. So both is required to handle the big data. Storing is one, not only the problem, right? So storing is one of the problem, but to handle efficiently the big data, we need both. We need HDFS and also we need MapReduce. So the fundamentals of this HDFS MapReduce system, which is commonly referred as a Hadoop. So whenever I say Hadoop, it covers both HDFS and MapReduce, both addressing the storage and also addressing the processing. Both combined term, we call it as a Hadoop. The basic unit of information used in MapReduce is a key value pair. So we are using this concept as a key value pair. So any kind of data, if you want to process in an Hadoop, that is a MapReduce, the data should cross across this phase. So all the types of structured and unstructured data need to be translated to this basic unit. What is that basic unit? Is nothing but key value pair. So let us see with some examples so that it is easy for you to understand. The first process is all the inputs, whichever the input we take to process the data, it has to pass through this phase, that is a key value pair. So before feeding the data to MapReduce model, so any operation you take, so before that we have to complete this activity. As the name suggests, the name itself says the MapReduce model consists of two separate routine activity. So the first one is map function, another one is reduce function. So these are the two major function I can say, so which decides the processing and which decides the accessing of the data and efficiently performs the operation. So here from this slide, the takeaway is that we understood what is MapReduce and how the MapReduce processing taken place, and what are the component broadly, what are the components we divided here is map function and the reduce function. So let us see in detail how the map function works and how the reduce function works, maybe with some examples. So here semantically the map, and see in the map, again the map has the two sub functions I can say. One is a map, another one is a shuffle. So these both phases are responsible for distributing the data. I mean, if I have a group of data, so the data will be distributed across, and finally there will be a reduce phase which performs a computation. I mean, it merge all the data together, and finally computation means some kind of calculation, some kind of mathematics operation will be taken place, and final results will be declared in the reducer phase. So there are two phase, one is map, another one is reduce. And the next point says a MapReduce has an extensive capability to handle unstructured data as well. Let us see one example. MapReduce can handle unstructured data. Map stage is a critical step which makes this possible. Mapper begins a structured to unstructured data. So whenever you perform a map function, so automatically it converts the structured data to unstructured data. So let us see one small example how it converts. For example, each one of us having photos, right? So we have the photographs in our laptops. So we might have collected the photograph from last 5 years or 10 years. I have a collection of photographs which is there in my laptop. So I want to count number of photographs on my laptop by the location. So now Google provides that, right? I hope most of you have that feature. Whenever you go to the gallery, there is an option like album. So when you click an album, based on the places, it groups, almost the Google groups all your photos based on the places, and by selecting the place, easily you can view the photos whichever you captured in the particular place. So here this is my problem statement. So what I need to do, I need to check the number of photographs on my laptop based on the location. You can say it is a city where the photo was taken. I need to analyze the unstructured data, because photos, obviously you all know that photo is nothing but an unstructured data. So here we need to process how this concept can be applied in the map reduce process. So here, to process this data, the mapper makes the key value pair. I told you. So we need to describe, we need to decide the phase, like any data you take, we need to save. We need to convert this into the key value pair. So here in the key value pair, the key will be act as a location. The value will be the photograph. Okay, so based on the key, the location, so for example Chennai, in a Chennai, how many types of photos I have taken, then the value will give number of photos you have captured in the location. So here comes, this is the one example I can explain you to convert the structured data to unstructured data. Finally, when you give this input to the map reduce process, it processes the data, finally it gives an output for you. So the place and number of photos we have captured in the particular place. So this is one small example. Maybe when we go further, we can see many examples. In a map stage, the mapper takes a single key value, because whenever I assign, I will assign a single key value pair. But as an input, it takes and it produces any number of key value pair as an output. Finally, the reducer will reduce that into the computational unit. That is a output. So here we understood, like, one, by taking a small example, how the unstructured data can be mapped, and finally it can be reduced to get the computation output. So here comes one important point. So we understood from the definition, we understood that MapReduce does the activity, the process in a parallel. So we need to know what we need to understand what happens in a parallel execution. So let us take a small example to understand here. In this diagram, you can see there are two portions. The first one, you can see moving data to a processing unit. I have 5 slave nodes. I can see here A, B, C, D, E. These are the 5 slave nodes. I have one master node. So in a traditional approach, how it happens? The data which is located in all the slave nodes will bring to one position, one place, that is a master node. So for example, if I have 1 TB of information in slave nodes, in each slave node, I have 1 TB of information. So all this 1 TB of information will be bring to one place, so that is a master node. What happens? Just think about the bandwidth. So if I want to transfer 1 TB of information from one single machine to a master node like this, from all the slave nodes, just think about the bandwidth required, and also the fault tolerant what it happen. In case of any failure happens, just think the data is lost. So, and also all the processing happens in the master node and the results will be declared. This is a traditional approach. But how it happens in the MapReduce, we need to understand. So here we are trying to understand the parallel processing. So parallel processing means what happens? So instead of you bring the data from the slave node to the master node for processing, you try to send the processing unit itself to the slave node. Let the data reside in the same node. Slave node need not to transfer the data to the master node. Master node, let us send in logic to perform the processing. That's what I'm saying, processing unit. You try to send the processing unit directly to the slaves. Let all the slave node does the operation parallelly. Instead, you run a program, or you execute a program, or they execute the data set in a one single machine, which takes a lot of time. Let try to do a parallel processing. All the slave nodes let process parallelly, because it is belongs to save slave node. Slave A has some certain amount of data. This slave A will execute part of the data parallelly. The same parallel time, all the remaining slave nodes also will execute the data. So this is nothing but a parallel processing. And also here you need not to bring the data to and centralized place. Data can reside in the same slave nodes. Okay, to understand this, let me give a small example maybe. So let us understand in a simpler way. For example, we all know like how the voting system happens in India, right? So how the voting system happens? So they decide the date when we need to cast our vote, and there will be a booth, for example, where we want to cast our vote. So it will be near to the centers, near to our houses. There will be, they will identify the different booth. So we as a public, we need to go there and we need to cast the vote. Am I right? So for example, let me take in a Chennai, in and around Chennai, they have decided around some 50 voting booth. Example I've taken. So all the 50 voting booth, all the public will go there and they'll cast the vote. Okay, so now all the 50 voting booths have the data. So in each voting booth, there will be a certain amount of data available. So okay, so this we'll call it as a slave nodes. So the both the voting both what we call is a slave nodes. And usually how the counting taken place in India. So whenever the election counting happens, they try to bring all the casted vote in a one particular place, centralized place, and they start counting the voting. So that is nothing but a traditional approach, because just think the kind of security, the kind amount of security we need to provide to bring securely about that machine from voting booth to the centralized place to count the vote. So that is nothing but a centralized, that is nothing but a traditional approach. You can assume that as a traditional approach, because we need to bring all the data from one place to the centralized place for counting the vote. But in a map reduce place, the same concept you try to apply here. See, you try to send, don't make the system to come from one place to another place. Their data, I can say, don't try to bring the data from one place to another. Let the data be located in the slave node itself. So try to send the logic. For example, in a voting system, so what happens, they have to send how to count the vote. So let you try to send an instruction from the centralized node to all the slave nodes, like how to count, how what is the procedure to count the votings. Let them process, let individual voting both, let them process counting the votes. Only after completing the task, all it happen parallelly, am I right? All it will happen parallelly. So once everything happen parallelly, you ask them to send the result itself. Instead of you bring all the data to one device, what you do, you try to ask them to send just a result. So take the results of A, B, C, D, E, and finally declare the result. So this is also one of the example I can explain here to make you to understand how the parallel processing and how the data locality works in map reduce concept. So you can understand so much difference is there when it comes to traditional and also map reduce. So I hope from these two diagram you understood that how the parallel processing happens, like advantage of map reduce I can say, and also the data locality, and how much overhead the bandwidth we are reducing by using this concept. Okay, so with this, let me go to the next slide. As I told you, each of the function, that map function and the reduce function, again it divides into subcomponents. I can say here Hadoop divides the jobs into two tasks. There are namely the map and the reduce. Inside the map task, again it splits into two things. One is the splits and mapping. So it passes through these two phases, that is splits and mapping. Under the reduced task, there is another two phases, that is nothing but shuffling and reducing. So these are the components we can understand it is available in the map reduce process. But who will monitor that? Who will take care of responsibility to schedule the job, give the job, run the job? So there should be some kind of tracker, there should be some kind of manager should be available to do this activity, right? So let us see who is responsible for that. The complete execution process is controlled by two type of entities called job tracker and task tracker. See, job tracker is nothing but it is located in the name node, because we have only one name node, right? So the job tracker will be located in the name node, and the job tracker is the responsibility to mark the resources, and also it has the responsibility to assign the task to everyone. So job tracker is one where it allocates and manages all the activity. So when it comes to the task tracker, so task tracker, since you know the data nodes, there will be multiple data nodes available, and in each data node there will be multiple data nodes. So whenever the job is assigned to the data nodes, the task tracker is the one who handles the data, and which will monitor the information. Just a minute. Okay, okay. So let us proceed. So here you understood there are two more components which is involved. Job tracker. Job tracker is responsible. It will be resided in the name node, which assigns the tasks to the data nodes. So under each data node, there will be another component called as a task tracker. Task tracker will be responsible to complete the performance and the task. So let us see more in detail what are the activities will be taken place between all this nodes. Okay, so as I told, for every job submitted for the execution in the system, the job tracker that is reside in the name node. Okay, we have one single name node. So in the name node, as the name node has the information about all the data nodes, so same way, name node will have one more component called as a job tracker, which is used to monitor and maintain the resources and also to allocate the jobs to the data nodes. So in data nodes, in each data node there is another component called as a task tracker. So task tracker responsibility is to receive the jobs from the job tracker and to complete the job. So these are the two components we have introduced here. Let us see more in detail like how it is processed and what are the activities it happens inside the MapReduce framework. A job, initially the job is divided into multiple tasks. See, any job you try to take, it will be divided into multiple tasks which are then run on multiple data nodes in a cluster. For example, I have a big job, so I'm going to break down the job into different pieces and I'm going to allocate. So the job tracker will allocate all these jobs to the data nodes and to perform the activity. So all the data nodes are in the cluster. So it is a responsibility of job tracker. Yeah, it is responsibility of a job tracker to coordinate the activity by scheduling the tasks to the task. So they will schedule the task to run on the different data nodes. Because we have a different data nodes, only the job tracker knows which data node holds which kind of information. Because job tracker is one who which coordinates all the tasks to be happen in the data node. So execution of individual task is then looked after by task tracker, which reside on the every data node execution part of the job. So here the execution, when it comes to the execution, completion of the job, so it is left to the task tracker. Task tracker is the one which should take the responsibility to complete the execution. So here comes one, I have taken one example. For example, task trackers produces the progress report. Because if I am running a job, just think about the data node number one. Data node number one has the task tracker which gives the progress report, and the job tracker will collect this information. It keep tracks on each job. So like this, from each task tracker the job tracker will receive the report and it keeps on tracking the information to complete the execution. So this is how the model works. Maybe if I explain with small example, it will be easy for understanding. In the event of task failure, just think one of the data node goes down or one of the data node crashes down. So what happens now? The job tracker is the responsibility to reschedule the job to the another task tracker. So with this, yeah, so here comes a small architecture you can see here. So client, it is a name node. Inside the name node there is a job tracker. We have three data nodes just for an example. So in each data node there is a job tracker. Job tracker does both map and the reduce task. So this is the architecture. What happens when the client, if I'm a client, I'll be submitting the job to the name node. Just assume I want to make a word count program. I'm going to give an example. I'm going to give a big example. For example, I have a huge number of photos in my laptop and I'm going to convert that into the key value pair. Okay, so I want the system to read my information, I mean my photos with the location, and I'll submit this job to the name node. So name node get the information and it assigns the task to all the data nodes based on the resources. For example, if the data node number one is free, it's idle, so it assigns the job, it's assigned the task to the data node number one. So based on the status of each data node, the name node, the job tracker will assign the task to all the task tracker. So after the task tracker individually perform the task, it happens parallelly. I mean all the data nodes works parallelly, and finally the system will consolidate the output. It gives the results for us. So this is a basic architecture, I can say, basic example like how the job tracker and the task tracker works and coordinate each other to complete the operation. So here you can see job tracker periodically gives the status update. It gives the status update, how much part of amount data is processed, how much quantity of the data is processed. So frequently it gives the information. In case, just assume like as we have seen the failure part. Okay, so in case the data node number one goes down, here we have three data nodes, one data node goes down, what happens? So when the job tracker stops receiving the status update, then it comes to know that yes, there was some issues happening. So what happened, the job tracker reassigns this job, the task which is given to data number one, we try to reassign this task to which are the node which is idle. So for the node which is idle, it reassigns the task, and the the process continues and it completes the activity. So this how the job tracker and the task trackers communicate each other to complete the task. So here just I have given one example, like uh, user submits the job on master, user is submits the job on master, master allocates the task to the slave nodes. So here the job tracker is there and the task tracker will be resided in the slave node, and the activity will be taken place. Finally the results will be declared and the update will be given by the master node. That the name node will give the updates to the user. This is just an graphical explanation, so I felt it is relevant, so I have added here. So okay, so let us take a small example to understand how this map reduce works by taking a small example. Most of you have already known about this. A small example is the default always we used to explain even when we take the classes. So here comes, I have taken the example. Consider that you have a following input data for your map reduce program. So we are going to consider, so here I have small data. So I'm going to give this as my input to the name node, and let us see what exactly happens in the map reduce process. So the data what I have is welcome to Hadoop class. Hadoop is good, Hadoop is good, bad. So this is my input, and I'm going to give this input. As we all know, inside the map there are two more processes, that is one is split and mapping. In the reducer we have shuffle and reducer. So you can see here the input welcome to Hadoop class is good, Hadoop is bad. So this is splitted. You can see here we have divided this input into four parts. That is nothing but a split process, split phase. After splitting the data, so from each split it tries to map how many times the key is repeated. So key, what is the key? Welcome is the key, two is the key, and Hadoop is a key. And number here it specifies one is nothing but a value. So here we are trying to make the input into key value pair. Okay, so welcome, under this block welcome is repeated only once. So welcome comma one, two, it is repeated only once. Hadoop one. So same way it tries to do for all the blocks, and finally the mapping stage you can see it has come to a key value pair combination. So once the mapper have this information, it tries to give to the next process, that is a shuffling. So now all these blocks shuffles each other and try to group again. You can see here it tries to identify the relevant key and how many times. Here you can see shuffling is nothing but you have given only one key value combination. I have a key, I have value. So key value pair you have given only one input, but output you can see here how many times we have got this key and also number value. So you can see here bad is repeated only once, class once, good once, and Hadoop it is repeated three times. You can see this is a multiple time the key value has been fetched here. So here multiple key value pairs we have, and here also is to welcome. So here from the shuffle stage we give this input to the next process, that is a reducer. So reducer takes the input from shuffle phase and it reduces based on the number of times the word is repeated, the key is repeated. You can see here Hadoop is repeated three times, so it is reduces to one component, one input, that is Hadoop comma 3. So finally if you see the reducer phase has a single key and the value is nothing but number of times the values key is repeated. So here you can see Hadoop it is repeated three times, is repeated for two times, two is repeated for one, welcome is one, bad one. So finally the reducer phase collects all the information, it compute and it gives the output. So finally this is our output we will get once you execute this program. Even I have the programs, so I'll be sharing the PPT, both the PPT. I have come up with one hands-on also. I'll be sharing that PPT to you all. So maybe you can execute whenever you're free. So here in this process, you can see we have given some input. So this is just for understanding, but even you can pass maybe 100 MB of data or 1 GB of data, a file as a file, if you give to the map reduce process, it easily computes within no time, and finally you get an output like this. So this is one example which I have wanted to explain here, how the map reduce process works. So here is another example I have with the same process. So here input data is a different, and the stages you can see: split, mapping, shuffle, and reducing. So and also you'll get the final results. So the process is simple. It is common for all the map reduce process and for all the data sets. So whichever data sets you pass as an input, and it process in this different phases, and finally we will get an output, the final result. Okay, so let me stop here, and I wanted to play a video. As I told, I'm going to play another video to understand how the educational analytics is taken place, and how the how this educational analytics helping the teachers to understand the students better. Okay, so with this, maybe I'll be sharing my video screen. Let me stop this, and I'll share the video now. I hope the screen is visible, and also I've enabled the audio. So I'm going to play this video. Please listen to this video. And they have discussed a lot of attributes, and they have come up with a lot of problems, and they have overcome the problems, and they have come up with very good outcomes. And it will more closely, it suits for us as a teachers, and even we can use such activities in our institute. So I'm going to play this video. Please listen to the video.
How do data help teachers? Teachers have access to more quality data about their students' performance than ever. This information, when combined with content knowledge, professional judgment, and quality training, can be used to improve outcomes for kids everywhere. Let's follow a teacher, Ms. Bullen, and one of her students, Joey, to find out how data help teachers and their students succeed. Before the school year starts, all teachers receive appropriate role-based access to data on their students' past performance, behavior, and attendance. This enables Ms. Bullen to set goals and create working groups specifically for her class. Throughout the year, she uses data and her experience in the classroom to see where Joey and his classmates excel or struggle, and targets her instruction to meet their needs. Ms. Bullen uses data about Joey's performance to show his parents what he's learning, how he's growing, and where he may be struggling. She also talks with Joey about his own data, and they work together to set goals. Throughout the year, Ms. Bullen and her principal review her performance data together to evaluate how she's doing with different students, standards, and concepts, and to note strengths and opportunities. Her principal uses information to help identify the best ways to support Ms. Bullen and her colleagues. Ms. Bullen and other teachers meet regularly for training and to use data to solve problems and identify promising practices. They also have access to powerful tools that let them know when kids may be getting off track. Midway through the year, Ms. Bullen sees that Joey is at risk of failing. Ms. Bullen works with Joey, his parents, and his other teachers to get him on track. By the end of the year, Joey's data shows that he's on track for success, though he'll continue to need support. When teachers are empowered with data, everyone does better. Learn more at dataqualitycampaign.com.
I hope the video was more relevant to us, because these are the activities we do every day. I'm right if you all agree with this point, because as a teachers, we usually get the students information, and we used to mentor them, we used to guide them, and sometimes whenever we identify that they are in the danger zone, or if they have need any kind of assistance, we might have conducted the special classes, tutorial classes, and also sometimes we used to interact with the parents. So whatever we are doing, it's exactly same, but the thing is that, so whenever we use a system, whenever we come up with a system to perform all this activity, it gives more weightage. So we sometimes we might have missed some of the data also. So sometimes will be missing some good amount of data, or sometimes we will need to gather more information to know about the particular students. So but this system, whenever you use the analytics into the picture. So all the data, whenever you use a big data concept here in the education system, so you can come up with very rich amount of data sets, so that it allows the teachers also to work on the data sets to understand better about the students and to give more benefit to the students community. So that is the reason I took almost I took the two videos on the education system, so that it is more relevant for us, and also we'll be using this somewhere whenever it is possible. And also it's only depends, only it can happen through the research. So we, as a faculty, even we can take and we can assign some of that task to the students also. Whenever they do some final year project or the mini project, we can give a small task to them, to say, to predict the student performance by giving some amount of data sets, to collect all the data sets of uh, different branches to accumulate in one particular place. Even the data collection also can be given as a small mini project, because it takes a huge amount of effort to collect the information to make them into the organized way. So whenever it is possible, let us start all this small activity, because performance prediction itself is not a big task. And also, for mentoring we can design a system, for admission we can design a system, for placement we can design a system. Because nowadays what happens, so we have a students, right? So we never make the students, for example, if I'm a student, each of the students have a strong area. Maybe the domain wise he'll be strong in, maybe the coding he'll be strong in, maybe the UI design he may be strong in, website designing. So what we can do, we can design a system, analytic system, where it groups the students according to their domain. And from the first year onwards we need to give a placement training according to his knowledge, according to his domain knowledge. So once we do this practice, and at the end, maybe when it comes to sixth semester or seventh semester, so we can target a set of companies where the expertise, his expertise will match with the skill set, and easily he or she can get placed in the company. So even for the placement activity we can use this big data concepts and also the Hadoop concepts to make the system more stronger. Admissions, there are many ways we can use this. So maybe we can talk to the higher ups, and we can give this some of the projects with students also to implement. With this, the next topic here comes is, what are the different types of clusters. So far we understood what is MapReduce, and we took some examples also to understand how the MapReduce works. And here comes like Hadoop. If I have Hadoop, we speak like the group of systems, the collection of systems are connected each other, and it is in the distributed manner, and also we call it as a cluster. So whenever I say cluster types in Hadoop, again it has a different types. So even I can have a one single machine. In a single machine I can run all the nodes virtually, and I can use as a Hadoop also. So here this slide gives a detailed explanation on how to categorize the cluster types in the Hadoop. The first one says the standalone mode. The name itself says it's a standalone, so we don't have a concept of data node, name node, secondary name node. In this mode there are no Hadoop daemons, so we call it as a daemons are the nodes. So Hadoop daemons generally we classify into three types: name node, data node, and the secondary name node. And also when it comes for MapReduce, job tracker, and task tracker. So all these nodes are not available, and that are running in the background. Just it uses and it runs in the background. As the name suggests, everything is a standalone mode, runs in a single machine. So that is the first category of cluster, I can say standalone mode. When it comes to second one, pseudo distributed mode. So in a pseudo distributed mode, pseudo distributed cluster is a cluster where all daemons, the name node, data node, secondary name node, all are running in one single node itself. So I'm going to make a single system as Hadoop, and also I have all the daemons. So here in our institute, we have a HP lab, so where we have formed both type of clusters. One is the pseudo distributed mode and also fully distributed mode. So whenever I want to access yes individual machine, I can use it as a pseudo distributed mode, and I assume all the nodes are in a single node, and we run the programs. So that is the second type, pseudo distributed mode, and all the daemons will be available in the single node itself. And when it comes to the third one, the name itself says the fully distributed mode. So when I say fully distributed mode, you can assume that if you are having the 50 nodes, if you have 50 computers in your lab, maybe you can decide which one you are going to make it as a name node, which one you are going to make it as a secondary name node, and which one you are going to make it as a data nodes. Okay, so this mode involves the code running on actual Hadoop cluster. This we call as actual Hadoop cluster, and you can experiment whenever you submit any job through a name node. So it distributes the job to all the data nodes which is connected under the cluster, and it performs the operation. So only when you try to implement a fully distributed mode, maybe we can experience the real-time scenario how it works with a distributed environment. So data are used and distributed across the many nodes. Obviously, whenever you want to place a write request, so morning we have seen whenever I want to place a write request, so name node will take the information and it gives the data node IP address wherever it is free, and we performs the operation. Different nodes will be used as a master node. Yes, we are not going to use the same machine for naming all the master node, name node, data node, and the job tracker, task tracker. So we use the different nodes to name all the daemons, and it runs virtually. Even it need not to be in the same lab, maybe even in the virtually even you can connect some of the devices and you can run. So here from this slide, we understood there are three different types of Hadoop clusters available. Namely, we called as a standalone mode and the pseudo distributed mode and fully distributed mode. So three types of cluster classification we can make. So here comes the next one. So next here it says map reduce functions usage in the industry. So in the morning session, I have told which are the top industries are using this Hadoop, right? So here comes some of the industries, companies, and also have listed here what are the activities they're uh, taking with the help of Hadoop. What are the activities they're performing? For example, at the first, if you take Google, so Google has indexing. We all know, because whenever we perform a Google search, so indexing will come into the picture. So to make the indexing building for Google search, they use the Hadoop. And also for article clustering for Google News. So to cluster the articles, I mean about the news, they use this Hadoop. And also the third one is a statistical machine translation. So for even for that activity, they use the Hadoop. And these are some of the activity from the Google. They use the Hadoop and the MapReduce concepts to execute. And the second, towards right hand side, if you see at the Facebook, to mine the data and to add optimization, because we have an option in a Facebook. We have an option that we can post an ad, right? So we can post an ad, so there to classify the ads and to group the ads. Still, I mean, the Facebook are using this Hadoop and MapReduce concept. And for detecting the spam also, they're using the Hadoop and MapReduce concept. And when you see at Yahoo also for index building, for the Yahoo search, they're using Hadoop. And for spam detection for the Yahoo Mail, again they're using this. At Amazon, product clustering, because Amazon one is the one where vastly they're using these concepts, and they perform a lot of analytics there to attract the customers to buy the products. Statistical machine translation, even that will be used at the Amazon. So all these four companies and the list of activities, they use these Hadoop concepts to get the more benefits. So I have told you so how the analytics is happening, right? So morning also I have given one small example. And in a real time, maybe you can see any business you take. For example, if I take a banking sector as an example, if I take a banking sector as an example, so analytics and the Hadoop works together to give the better results. For example, bank manager, there will be a regional manager, there will be one regional manager, bank manager. He analyzed the data of past, like for example last 4 to 5 years data he has collected about the ATM machine. So just take any example like HDFC banks or Axis Bank. So the area regional manager had an analysis report about the past 2 years or 5 years report he has got. And he understood, after analyzing the historic data and the present data, he understood that he identified some 10 areas, 10 sub-locations around Chennai. He understood that there are demand for this ATM machine. So public are moving from one place to another place to withdraw the amount or to deposit the amount. So what he did, immediately he taken action. He wrote, he got a confirmation from the head office to implement 10 ATM machines in the different location where he has the strong analysis. So ATM, the manager decided to implement a new ATM machines in all the 10 areas where the real demand was there. Okay, so once he has implemented, he has installed the machines. So his job is done. If we think as a manager he completed his job, no, it is not completed. Whenever you say analytic and Adobe comes into picture, even we need to check whether we have any gaps there. For example, after 2 months, the bank manager again he had an analysis. After installing the ATM machines, he took analysis and he has checked out of 10 ATM machines, he got the information that two more ATM machines are not performing well. I mean, they're not getting more customers to access the machines. Okay, so what he decided? So he somewhere he missed the gaps. So to fill that gap, what he did, and he understood that out of 10 ATM machines, still some of the areas are more demand. Still, the people are coming to access the ATM machines. Even the one machine which is installed is not sufficient. So what he did, he took those two ATM machines which is underperformance. I mean, nobody is using that, and he removed and he has installed in other places where it is demand. So here, yes, he is acted purely on the data. See, as a manager, he would have taken on his own examples he has taken, he would have given his own explanation to do some activity. But everywhere, every domain you take, every location you take, they are using this Hadoop and the big data concepts to analyze the data. Only data will speaks. No human intervention. Human intervention will be there only for taking the decision based on the data available. So even the Google, Yahoo, Amazon, everywhere the data speaks. So only by having the data, they are coming with the decisions, they are coming with the promotions, they are coming with the ad. So many activities is happening under all these four areas. So let us go with the next slide. So here comes, so far we understood what is MapReduce. We took some examples, and also I told that I'm going to share some hands-on materials to you all. Maybe you can execute whenever you're free. Even if you wish, you can put a message in the chat box so that even I can share a software that is a Cloudera software. I can share with coordinators. So in maybe the coordinator can collect all the materials and they can share with you. So you can use that software and you can run all the uh, MapReduce programs and the HDFS concepts in your laptop itself. So with that, let me go with the next. Here comes the next. What is Hadoop 1.x? So we have seen what is Hadoop, we have seen Hadoop HDFS, we have seen MapReduce. Whatever we have seen so far, it is a common platform which they run in all the three versions. Now we are trying to understand what is the issues in Hadoop 1.x version. What is the limitation? I can say what is the limitation, or you can tell me what will be the problem, so that why they are moved to the next version. So let us see one by one. So main drawback of Hadoop 1.x is itself the MapReduce component in its architecture. Because in Hadoop 1.x there was no concept of secondary name node. They had only one node, and the MapReduce, that is a job tracker. Job tracker is only one who is more responsible. It is more overburdened, and so let us see one by one. It is only suited for batch processing. The first point everyone should remember here is the first version when they released the Hadoop, that Hadoop was not suitable for the real-time processing. In a real-time scenario, I need to use some of the Hadoop tools, maybe the Scoop or Piglet. So I'll use some of the tools to feed the real-time data to my system. That was not supported by the Hadoop 1.x. So Hadoop 1.x was more suitable for the batch processing. Whenever I say batch processing, it means that you have the data ready with you. I mean, you have some warehouse or you have some data servers where you collected the data already, you warehoused, and just thing is that you need to give the data to the Hadoop architecture to process it. So that we called as a batch processing, and also a huge amount of data. So it can be a big data, so it can be any number or any amount of data that you have already collected and warehoused, that can be feed to the Hadoop architecture 1.x, which is already in the Hadoop system. It is not suitable for the real-time data processing or the data stream, because nowadays, morning I have told one example like how Amazon are attracting the customer to make the customers to buy the product, right? So the same way, how they are doing, they're performing the real-time analytics. So with the real-time analytics only, easily we can able to attract the customers. And even we as a lecturer, as a professors, even we can take some of the students real-time information whenever they're into institute, they're in the campus. So to monitor them, to know about their progress in the laboratory or in the classroom session, sometimes we may need to get the real-time information also. So in that case, Hadoop 1.x was not supporting for the real-time processing. It was just for the batch processing, and it has capacity of 4,000 nodes per cluster. So even there, in the number of nodes in the cluster was had the limitation. They had only a maximum of 4,000 nodes are allowed to form a cluster in the Hadoop 1.x. And here comes, it has a single component called as job tracker. As I told, there's one single component, job tracker, to perform many activities like resource management, job scheduling, job monitoring, rescheduling the job. All this activity has to be maintained and managed by the job tracker. Just think, if that one node goes down, the entire architecture will be failed. So here, job tracker is a single point of failure. Yes, because we didn't had a secondary name node in the Hadoop 1.x version. So we had only one name node, and there'll be multiple data nodes. So it is a single point of failure. That was a big issue they had, and it runs only for map reduce jobs. So you have huge amount of data already into the platform. You give the task to execute. It efficiently gives the output for only for the map reduce jobs. Let us try to understand how Hadoop 1.x the resources were going waste. For example, it follows slot concept. In HDFS, just assume there are 20 nodes in a cluster. Okay, so there are total 20 nodes in the cluster. So you have decided 10 nodes to perform the map function. You have assigned, I need a 10 nodes to perform the map task, and the remaining 10 nodes to perform the reduce task. So once you decide that the nodes, so when the reduce node can get the information, after once map reduce map function completes the task, the completed task can be given for the reduce node. Am I right? So whenever the map task is executing the program, all the reduce node will be idle. So what drawback here is, once you assign the 10 nodes for the reduce, so we may not use that nodes for any other purpose. It will be idle, but still we are not able to use that idle node, because already I have allocated, these are the nodes for map, these are the nodes for reduce. And unless until it completes the transaction, all the 20 nodes will be, some of the nodes will be idle. In any of the time, any point of time, there will be 10 nodes will be idle, and we may not be in a position to use that. So that is the explanation I've given here. It follows slot concept in HDFS to allocate the resource, that means a memory, RAM, and CPU. It has a static map and reduce slot. There is no dynamic. So dynamic means whenever the job comes, during that time the allocation should happen. But here it is a static map and reduce slot. That means when it assigns the resource to map or reduce jobs, it cannot reuse them, even though some slots are idle. So that one example again, suppose you have 10 map and 10 reduce jobs are running with 10 plus 10 slot to perform a computation. Have 10 nodes for map and have 10 nodes for reduce. All map jobs are doing their task, but all reduce jobs are idle, because once the map job completes, the output will be given for the reduce job. So by the time the reduce nodes all will be idle, but still we cannot use the idle jobs for the other purpose. So there is a big drawback was there in the Hadoop 1.x version, and I hope you understood here the limitations. The limitations is, it is mainly suited for the batch processing, and no real-time analytics was real-time processing happened, and has the limitations in the number of nodes, and overburdened by the on the job tracker, and it is prone to the single point of failure. It runs only on the map reduce jobs. So these are the some of the drawbacks which they have identified. And as you all know, in the year 2012 they have come up with a new version called as Hadoop 2.x. So in Hadoop 2.x architecture, along with Hadoop and MapReduce, they have introduced one more component called as Yarn. So yarn is another is nothing but yet another resource negotiator. Let us try to understand what are the advantage and what are the issues we have overcome from 1.x to 2.x. So in 2.x, you can see it allows work in MapReduce as well another distributed computing models. For example, I have some tools, like I have Adobe ecosystem tools. I need to bring some real-time information from FB, Facebook. I need to use some of the APIs. I need to bring real-time information from the different source. This allows. This Adobe 2.x will allow to perform the real-time analytics. So it has a better scalability because they have scaled up to 10,000 nodes per cluster. In earlier, we had only 4,000 nodes maximum. We can have it in one cluster, but here they have scaled up to 10,000 nodes can be contained in one cluster to form a Hadoop. So work on the concept of container. So here the concept of container will be used whenever there is a job is scheduled. The container has the generic task which has to be performed. Even if you want to prioritize which job has to be performed first, which job has to be performed later. So everything can be configured here, and it can perform the generic task here by using the container. So here it has a multiple name node serves manages multiple namespace, because as we have seen the architecture in earlier, I've shown you name node and the secondary name node. It is a architecture of 2.x, so which has multiple name node, but it is not going to replace the name node, right? So passive and active. So passive and active passive will not replace the active name node. It will be there just to get the update of the name node to the secondary name node. So which has multiple namespace also. 2.x has a feature to overcome the single point of failure. Yes. So even the name node goes down. When the name node goes down, so we'll manage to continue the operations by having some information which is located in the secondary name node, because secondary name node will have the current update about the name node, because every frequent of time name node will update the fs image and the edit log to the secondary name node. Okay, so in that case, for example, if the name node goes down, still operation is continuing. After sometimes if name node come back to the process, what happens? The secondary name node will have the updated information, am I right? So secondary name node will give the updated fs image and edit log combined version of that is called as a checkpoint. So the checkpoint will be given back to the name node to update the fs image and the edit log. So this is the continuous process. Morning I have shown you the diagram how the name node and the secondary name node connect each other to update the fs image and the edit logs. So it overcomes the feature of overcomes the single point of failure with a standby name node, and in the case of name node failure, it is configured for automatic recovery. Yes, the process is designed in such a way that whenever the name node comes back to the process, automatically the secondary name node will give update the information to the name node. So the last point here is it can serve as a platform for a wide variant of data analytics, possibly to run event processing, streaming, and the real-time analytics. See, after the year 2012, most of the industries have a revolution started saying that to understand the customer's behavior, to understand the customer's likes and dislikes, you take any kind of portal, you take maybe the Amazon, you take the Google, so they will try to understand our needs, and they have come up with proper recommendations. So that the only reason is they could able to get the real-time information. So they're able to get the streaming data, which is lively running in some sources. They're able to manage to get the data by using this advanced feature, that is 2.x in the year maybe 2012 to 2014, 13, 14, 15. All those years they were using this 2.x version. So I hope you all understand this, the limitations of Adobe 1.x and some of the advantage of this 1.x. Only it suits for the batch processing, and all these limitations we have overcome by using here in the 2.x, and some of the advancement has lead to benefit for lot of organization in the year like 2012 to before the release of 3.x, that is 2017. So they were getting a lot of benefits over there, and with this, by having these two information, now we need to make ourselves to understand what are the new features. We understood now Hadoop 1.x we know, and Hadoop 2.x we know. and also we know how the architecture works, how the MapReduce works, everything we know. Now we need to be in the position to understand and to know about the features of 3.x, because right now currently we have an Adobe, the latest version is 3.x. So let us try to understand what are the features, what are the different features available in Adobe 3.x one by one, and maybe at the end. So that is my last topic. Maybe at the end I have one more video to play for you, and I'll be happy if there is any questions to address. So with this 1.x and 1.2.x limitation, so let us try to understand what are the new features there in the Adobe 3. So Adobe 3, the release of Adobe 3.x is the next big milestone in the line of Adobe releases. Many people have a question in the mind about what features enhance does Adobe 3.x gives over Adobe 2.x. So this is a broad area I can say here. It comes because it is open source. I told you, even you can install this softwares by going to the official site. You can get the softwares, you can install them, you can use. The main thing is that at the back end we need to know how the architecture works and how the activity works. See, we all know like how the read write operation happens in HDFS, how the block is dividing into the, I mean the file, the user file is divided into the blocks. All the basic fundamentals we learned in this 2 sessions, and now we have come here to the final phase, that is to understand the feature of Adobe 3. As you can see, there are features are listed here. You can see the first feature says towards the left hand side, so the minimum version, because all the Adobe jar files have been configured to JDK 8.0. So if you want to use Hadoop 3.x, any of the versions, the minimum requirement for you is Java 8.0. In case if you are using 7, you need to upgrade to 8. So that is one thing, and you can see the second one, it supports the erasure coding. Okay, so most of you might have got this doubt. For example, when we come with the replication, what is the issue we are facing with the problem of replication? Because if I have 128 MB of block, let us name it as a block A. If I have a block A with the size of 128, we know already, we know by default Adobe 2.x and Adobe 1.x has the replication factor of 3. That means to store a block A 128 MB, I need to have 3 times the space, because it takes 2 replication and 1 actual data will be there. And just think here, so we are using, and most of you may think that if I have 1 TB of information, then it will utilize more than, it will utilize 3 TB information to have the replicas. So but what happens, they somehow they have made to reduce the storage space, they have come up with some new logic here to have a parity bit. So here they have used the concept called as a RAID, redundant array of independent disk. By using that concept like stripping and the parity, so they have come here and they have reduced uh, the overhead of a space by 50%. Let us see in detail. Here the erasure means it is going to reduce the replication space by reducing the number of replications. So here they are using the parity, a parity block, and by having the parity block, they are drastically reducing the replication size and also overcome the failure. So we'll see this in detail. Maybe it has a distributed scheduling, yes. So which has, for example, it allocates the jobs. We know that in Adobe 1 point and even in 2.x also that's the distributed scheduling. But here the difference is, whenever you performs the job, whenever the Adobe assigns a job, so it distributes the jobs across all the nodes, and also it happens dynamically, not statically. So dynamically it gives the jobs to all the data nodes. Whenever there is a failure happens, dynamically it changes the data node and it performs all the tasks in the distributed environment. So here the yarn, they have come out with a new version, the timeline service. We had a yarn in Adobe 2.x also, but here they have come up with a different version. In Adobe 2.x version, they had yarn version 1.0, but here they have come up with a new version. So let us see what are the advantages there. And here it comes the opportunistic container. So opportunistic container, we know what is meant by container. Container hold all the jobs which is scheduled by the job tracker, because job tracker is one which schedules the jobs. So the container will hold all the jobs which is scheduled, and it uses the queue concept to schedule the jobs, and it gives the jobs to the all the data nodes. But here opportunities container is, for example, you your job tracker has, and we have multiple task tracker. See, when the job tracker assigns the job to the data node, whenever the data node is idle. But here in 3.x there is a feature called as, even though the data node is not free, even though if the data node and the task tracker is not free, not idle, still the job tracker assigns the job, and that will be contained in the opportunistic container. It will be located in the opportunistic container, and whenever the node becomes idle, then it will be scheduled. Okay, so the one of the main advantage, because to improve the performance, this is also one of the important aspect which is contributing here in the Hadoop 3.x version. So which has the revoked daemons, because here we have multiple name nodes, and also we have a different nodes we have available. Let us see that. And here it comes another advantage called as intraday data node balancer. See, node balancer is one of the key term even we have used in 1.x and 2.x. For example, if there is a rack, in a rack there are 10 data nodes available. Okay, so if it balance within the rack, we call it as an intraday. So interdata node balancer happens, but here in 3.x, even intra node, for example, between the rack, if there is a nodes, if they want to balance each other also, it can happen here in the 3.x. And the last advantage you can see here, more than two name nodes we have. Okay, so here there is a passive nodes will have multiple passive nodes will be there, and even it goes up to 2 times failure. For example, if 2 times if the name node fails also, still this system executes, still if the system runs. Let us see all advantage, maybe step by step we'll try to understand with some diagrams and explanation. I think we are on track, and I'll be taking for another 20 minutes, and after, when we reach at 3:30, maybe we can conclude and we can have some question and answer session. Before that, I'll summarize the topic, the entire topic, whatever we have seen in the forenoon session and also in the afternoon session. So here comes the first feature. So we have seen the minimum version of Java supported in Hadoop 3.x is JDK 8.0. So if you are running, if you are using Hadoop 7, just try to upgrade to the Hadoop 8. So because the reason is, we have compiled all the Hadoop jar files using Java 8 runtime version. So it is mandatory, it is a minimum requirement to have a user to have this Java JDK 8.0 to execute all the, to use this Hadoop 3.x efficiently. So that is the first advantage. And the second advantage here it is Hadoop supports error share coding. So here, please try to understand what was the problem we are facing. See, that was not a problem, but most of us, we think that why we need to use a lot of memory to have the replication. Do we have any technology? Do we have any techniques to reduce that? Because whenever I say one, so you can see here, I have 128 MB of block, right? In the 128 MB of data has the two replica, then it is 200% extra data storage we are using. So let us try to understand this. So HDFS supports erasure coding in Hadoop 3.x, which provides a fault tolerant. Even though it reduces the number of replication, still it provides the fault tolerant. Hadoop 2.x uses the replication techniques. Obviously, we all know the default replication factor is 3, and also it has a high fault tolerant. Let us explore the difference between these two. Okay, for example, we will look at the replication. Let us take the default replication factor is 3. In this case, 6 blocks we have to store, a total 6 into 3, because I have to store 6 blocks. Each block has a size of 128 MB. So forget about the size. I have a 6 blocks. I need to make a 3 copy of each block. 6 3 is 18. So total I'm going to use 18 blocks of replication factor as a 3. It utilizes a huge amount of storage. It takes huge amount of storage for having the replication. So which has a 200, because each replication stores over it is 100. Whenever I create a replication, the percentage of overhead is 100. So here I have 2 copies, then the overhead is 200. So hence in our case, the storage overhead will is 200. And that was doing really good, but only thing is that to consider this, to reduce the overhead of storage, do we have any technologies? Yes. So in Hadoop 3.x, they have come up with the technology by combining the technology, that is a redundant array of inexpensive or independent disks. So by using this concept, they made the overhead from 200% to 50%. Let us see how it happens. So erasure coding has a two kind of process. One is encoding, another one is a decoding. See, whenever you use 3.x and whenever you want to create a replication, so for example, for 6 blocks, okay, so for 6 blocks, here number of parity blocks will be 3, 50% of the data blocks. So here we have 6 blocks. In a previous example, we saw for 6 blocks, we need total 18 blocks, right? Whenever we create a 3 replicas, 6 into 3, 6 3 is 18. Total, we need 18 blocks to store the 6 block information. But here, out of 18, we are making a 50%. We are going to reduce that by 50%. That means we are going to have a 6 block of actual data, and we'll be having a 3 parity blocks. Both will be calculated, and there will be total number of blocks will be only 9. Out of 18, we made it to 9. That means we have reduced the 50% of storage by using the concept of parity block. So this process, whenever you calculate the parity for the given data blocks, we call it as an encoding. So encoding is nothing but when you calculate the parity block for the given data block. So we call this encoding. For example, decoding. The meaning of decoding is whenever any failure happens, this block get missing or corrupted. Maybe just assume I have a block A. Block A is damaged or it was crashed. What happens? It get calculated from the remaining blocks and the parity blocks. There will be a parity block which both of the block will be calculated. Finally, we can able to retrieve the information. So that process we call it as a decoding. So please try to remember this terminology, like encoding, which we calculate number of parity bit is required for the data blocks. Decoding we use whenever there is a missing data happens, whenever the block is missing, to retrieve the block by performing some addition and subtraction. We call the process is decoding. So okay, let us try to understand with small example in the diagram. In this case, we have a total 9 blocks storage. For the 6 block, it makes 50% storage overhead. In the previous slide, you understand there are 18 blocks is required. Yes, we need 18 blocks, and also with 3 replication factor to store all 6 data blocks. But here, to store the same 6 blocks, we need only 9 blocks. You can see the architecture here. Okay, so for block A1 and for block A2, for combining both this block, we have a parity bit called as block A parity. Okay, so for block A1 and block A2, which combines, and there will be one parity bit called as block A parity. In the same way, for block B1 and block B2, there will be one parity, and for block C1 and block C2, there will be one parity. Just you can assume, maybe if C1 goes down, or you can assume the first row itself, you can just consider that A1 is gone, it has destroyed or it has crashed. So where exactly this replication is available or the data is available, it is there in the parity. So what happens, this block A2 and parity works each other, and finally the block A1 will be replicated. So if block A1 is not available, when some user is requesting the data to access the A1, so what happens, the parity bit and the block A, because it is both the combination of A1 and A2 is nothing but a parity, right? So it applies the mathematical calculation here to get the block A1 information, and that information will be given to the user. So with this technique, 50% of overhead as one parity block stored for 2 data blocks. For both data blocks, there will be only one parity. So with this, we are reducing the overhead of 200% to 50%. This is one big advantage I can say when you compare with the 2.x and 1.x and the replication factor. This is how we have overcome here. Okay, next comes Yarn Timeline Service version 2. I told you because why they are main named it as a version 2, because it is the first version of Yarn. It is introduced in 2.x. Here in 3.x it is a version 2. So here Yarn Timeline Service is a new in Adobe 3. Timeline service server is responsible for storage and retrieval of an application's current and historical information. So Yarn here, the timeline service is responsible for retrieving the historical, that is application current information and the historical information. Let us try to understand this. This information is of two types. The first one, the generic information of the completed application. So for example, if already completed some task, if there is an application which is running on the student database, so student education system, so if already the task is completed, that application is completed, so if you want to get that information, name of the queue, user information, number of attempts per application, information about the container which run for the each attempt, so all this information will be available in this Yarn timeline, and easily we can get this can be serves the historic information also whenever it is required. And when it comes to generic data stored by the resource manager about a complete application which is accessed by web UI, so here it accesses the data called pre-framework information about running and completed application, number of map tasks, number of reduced tasks, what are the different counters available, information published by the application developers to timeline server via timeline client. So this entire feature speaks about a current application which is running and also the past previous application. See, whenever I run any current application, in case the current application requires some of the previous executed commands, so this Adobe timeline version 2 will make sure that so it feed the historic data also to execute the current application. So these are some of the advantage, some of the tasks which we have overcome when you compare with 2.x to 3.x. So the next feature, it supports for opportunistic container in the distributed scheduling. So I told you what is the meaning of opportunities. Opportunities container is nothing but without having any resources, even though there is no resources available in the data node side, because data nodes should be idle or it should available to perform the task. If it is not available also, still the job tracker will give the task to the data node. All this information will be stored in the opportunistic container. This will be later assigned and jobs will be continued. We'll see how it is happen. A new execution type has been introduced, that the name called as opportunistic container, which can be dispatched for the execution at the node manager even if there are no resources available at the moment of scheduling. So who will schedule the job? The job tracker will schedule the jobs, and even though there is no resources available, the node manager hold that in the first come first serve order as in a queue, and whenever the resources comes, it automatically assigns the jobs to the data node. So this is fantastic because the job tracker need not to wait for the resources to allocate. So whenever the resources makes idle, whenever it comes idle, automatically the node manager itself assigns the task to the resources, I mean the data nodes to complete the transaction. In such a case, these containers will be queued at the name node. So waiting for the resource to be available for it to start. Opportunistic containers are of lower priority than the guaranteed container. So we know there is a container in 2.x version. So guaranteed container has a timeline there. It has to be executed in a specific time. So priority wise when you check, the guaranteed container will hold the highest priority. Whichever the job is located in the guaranteed container, it will take the highest priority, that will go and execute first. And when you speak about the opportunistic container, it has less priority and it allocates, it completes the task when there is no jobs available in this guaranteed container. So that are preempted if needed to make a room for guaranteed container. So even you can preempt, you can change the priority and you can allow the jobs to be executed. This should be improved cluster utilization. For this, these are the purpose why we use. For all purpose is to improve the utilization and to make the better execution, to reduce the execution time also. Okay, so here comes the next feature. Okay, so yeah, we are on time. So it comes the next feature. Next feature is to support more than two name node. You can see here till now Hadoop supported only single active name node and single standby name node. There was only in Hadoop 2.x version, 2.x version, there were only two name nodes. One is active name node, that is a name node, and there was a passive name node that we call it as a secondary name node. But here in Hadoop 3.x, just think about the Hadoop 2.x, even both the node fails. Will it, you want the process to stop the execution? Sometimes we may running a difficult application, sometimes we are running some important application where it should request a lot of amount to complete the transaction. So just in that case, all these important applications may be used in this 3.x, because here you can see I have one active node node, two passive name nodes. So here in this case, you have many name nodes. The point of failure, it reduces still. It gives an efficient operation. Always there will be only one active name node. Whenever this active name node goes, the first passive name node will come into the picture. It takes over and continues the operation. Even this goes down, this will come and this takes over and continues the operation. So here you can see the journal node, the meaning of journal node, which monitors and schedules all these active nodes and passive nodes. So journal node is nothing but a node which monitors all this active and passive nodes, when to aggregate, when to remove, when to reschedule the jobs. All this activity of this passive node and the active name node will be monitored and maintained by this journal nodes. And we have a data nodes as usual, the architecture. So journal nodes are the one which will perform the synchronization activity between the active and the, it synchronizes which one should go. In case of failure, the journal node will reassign the passive node to the active node. So all this activity will be taken care by journal node. Since there are three name nodes, we have five journal nodes. In Hadoop 2.x, since we have two name nodes, there will be three journal nodes. So this depends, again, whenever you increase the name node, even the journal node also get increased. But data node is depends how much ever the cluster size you want to design, and how much ever data nodes you want to have, you can have and you can design. Even if you want to have 2 racks, 3 racks, a single rack with multiple nodes, all is possible here in this nodes. Okay, so I hope you understood here. And the last one, the feature here, the last feature says that here actually the port names. Okay, when you compare with the 2.x and 3.x, the port number have been changed. You can see here for the name node in 2.x, we had a port number as nothing but 8020, but it has changed to 9820 in Adobe 3.x version. So these are the changes, these are the updation have been made from the 2.x to 2.3x, 2.x to 3.x. So all this updation have been made. Whenever you execute a standalone mode or the pseudo distributed mode, easily you can see all these nodes. Whenever you execute, whenever you install the software in your machine, automatically you can see all these port numbers. And this indicates that whether the name node or data node or the secondary name node will be active or it is not active. So this is one changes. And the last feature, here comes that intra data node balancer. You can see here, so in even in a 2.x we have a balancer, but not an intra data node balancer, which balances the node. The distribution of the weight of the node can be done only within the rack. So if I want to do here within the rack, I'll do. But here in Hadoop 3.x version, it allows to do the intra data node balancer also. Between the nodes, it allows to balance, and it performs the balancing operation between. This is the inbuilt operation. It's not like a user has to perform this operation every time. It automatically happens, it automatically performs, it balances all the resources and the size among all the data nodes evenly. So during a write operation, because whenever you perform a write operation, what happens, sometimes we eventually we fill the data in all the data nodes based on the number of blocks. So here whenever you fill the data eventually with all the data nodes, sometimes the balancing has to be taken place. The same node should not be repeatedly filled with the data. So all this activity will be taken care by this intra data node balancer. Okay, but when we add or remove the disk, it results in the significant snow. Because if I remove the disk, where it should go? the content which is available in data 3, disk 3, it should be filled with other data nodes, right? So all these operations will be taken care by the node balancer. Okay, so before I conclude, I told I have one more video to play. So please, this video is to play know about uh, the data center, because I told you there is a Google data center. uh, how exactly the data centers and the node, easily you can see here the racks, the nodes, everything we can see. So I'm going to I'm going to play this video. uh, Let me check. So I'm going to share that video. So I'm going to share with audio also. So please listen to this. Just as a takeaway, maybe you can understand how the data center works, the Google data center works here. So I'm going to play this video. Please request the participants, professors, to just observe this.
Operating data centers.
You can see here, this is the rack. So in each rack you can see there are different number of nodes. So each node we call it as a, I mean, each rack we call it as a nodes here. Inside in an individual rack you can see there will be n number of nodes will be contained. Among this node, some of the nodes might have named as a name node, a data node, or the secondary name node, or the passive name node also. Okay, let me play this video.
I'm Joe Cava, Vice President of Data Centers at Google. I'm responsible for managing the teams globally that design, build, and operate Google's data centers. We're also responsible for the environmental health and safety, sustainability, and carbon offsets for our data centers. This data center here in South Carolina is one node in a larger network of data centers all over the world. Of all the employees at Google, a very, very small percentage of those employees are authorized to even enter a data center campus. I think the Google data centers really can offer a level of security that almost no other company can match. We have a information security team that is truly second to none. You have the expression, they wrote the book on that. Well, there are many of our information security team members that have really written the books on best practices in information security. Protecting the security and the privacy of our users' information is our foremost design criteria. We use various layers of higher level security the closer into the center of the campus you get. So just to enter this campus, my badge had to be on a pre-authorized access list. Then to come into the building, that was another level of security. To get into the secure corridor, which leads to the data center, that's a higher level of security. And the data center and the networking rooms are the highest level of security. All of our racks don't really look like a traditional server rack. These are custom designed and built for Google so that we can optimize the servers for hyper efficiency and high performance computing. To me, the thing that amazes me about Google and the data centers is the pace of innovation and always challenging the way we're doing things. So when people say that innovation in a certain area is done, that we've kind of reached the pinnacle of what can be achieved, I just laugh.
Yeah, so I hope this video. So if you ask me a question, like even some of our Gmail, so the drive information, whatever we have, whatever the information we have shared in the drive, even some of the information might have located in some of the nodes in the data center, what I have shown in the Google data center. So here the thing is that they have very vast data center, and which stores all the worldwide information has been stored in the Google data center. And even some of our data sets also, some of our data also have been located, might have been located in the data centers. So with this, and also for today's afternoon session, let me summarize the session topics. In today's afternoon session, we started with the revision of HDFS, and follow to that I just explained about the MapReduce, introduction to the MapReduce, and what are the components or what are the daemons are there in the MapReduce. We understood each of MapReduce components, like the mapper task and the map function and the reduce function, the job tracker and the task tracker. And we have taken some examples also to understand how the MapReduce process works. And follow to that, we understood like what are the different types of clusters available in the Hadoop, and slowly we stepped into the limitations of Hadoop 1.x. comparison of 1.x with the 2.x, and finally we saw the features of 3.x and what are the advantages which had when you compare with 2.x to 3.x. So and also we have seen some two videos how the real-time analytical happens. One is on education system, another one is Google data centers. So these are the content which we have seen, and these are the takeaways for all of you. And I hope you enjoyed the session. And I am happy if there is any questions to me, I'll be happy to address the questions. So now it's over to the organizer, and if any participants have any of the questions, maybe you can unmute and you can ask the questions directly to me. Or in case if you want to put a message in the chat box, even you can put the questions in the chat box also. So now it's over to the organizer. Thanks.
Okay, sir. Thank you, sir. Participants, if you have any queries, kindly please answer.
So feel free, please unmute your mic and you can ask the questions in case if you have any doubts or any clarification.
Queries may also given in chat box also.
Yes, they can use the chat box also. Even you can put your questions in the chat box. Yes. No. Okay.
Shall we conclude, sir?
Yes, ma'am. Sure, ma'am. Sure. They can. I'll be sharing the presentation to you, ma'am. Maybe you can share the presentation to the participants in case if they want any clarification, if there are any doubts. I have shared my email ID and the contact number. Even they can approach to me directly also. Thank you, ma'am.
Sure. Okay,
So
sure.
yeah, before I hand over to the organizer, let me thank the organizer, the entire team, Excel Engineering College, the principal department, the computer science department, program coordinator, and all the coordinator members for accepting, for giving the opportunity to interact with all the participants here. And also I thank and I wish all the very best for the participants for the remaining 4 days. Thank you, ma'am. Please.
Thank you, sir. So first, I have to thank Kiran Kumar sir for his valuable content information in the topic of MapReduce, introduction to the MapReduce and Hadoop. So in morning sessions, I have covered the topic of Hadoop and MapReduce and steps involved in MapReduce framework. And also, sir explained in detailed manner about the clustering types in Hadoop. And in afternoon session, how the MapReduce functions are used in industry. And also, sir explained versions of Hadoop, Hadoop 1.x and 2.x, and how we are overcoming the drawbacks in Hadoop 3.x, and also explained about the features of 3.x. So today we got a valuable information in the topic. So on behalf of the Department of Computer Science and Engineering, College, we thank Kiran Kumar sir. Thank you,
Thank you,
sir.
ma'am. Thank you. It's my pleasure to be part of this STTP. Thank you so much.
Thank you, sir. And I thank all the participants for completing today's session successfully and also resource person. And feedback link is given in the chat box. I request the participants to give the feedback without fail. And one more kind information for the participants. For tomorrow's session, the requirement kind information is the participants may install the MATLAB software. Tomorrow's resource person is going to give the hands-on training. So I request the participants, if possible, to install the MapReduce framework. MATLAB software. So once again, I request the participants to give the feedback without fail. Shall we end the session, sir?
Yes, ma'am. Sure, ma'am. Thank you. So we can end.
Thank you, sir.
Take care.
Thank you, one and all.
Still, the feedback link is not working.